Hi folks, we're going to take a look at number 11 on the Unit 5 assignment. So it's a tide question. So they give us the maximum and minimum heights of the tide, and they give us times at which they occur. So notice that these times are from the maximum to the minimum. So that's just going to represent half the period. Keep that in mind when we do our calculations. Okay, and they tell us that this model is going to work until July 31st. So that means we're looking at 2 months or 61 days worth of time. So they want us to determine a model, and they're very specific. They want the model to start at 12 a.m. on June 1st. So right off the bat, I see that the maximum occurs at 3:38 a.m. So I'm probably going to need a phase shift. All right, and then once we have that model, we want to determine when the tide is at sea level. In other words, when it has a height of 0 between June 1st and July 31st. All right, so let's get started on finding the model. So we have our maximum of 8.2. We have our minimum of negative 0.6. And so from these two, of course, we can find the A and C values of our model. So A is just going to be 8.2 minus negative 0.6 over 2. And C is going to be 8.2 plus negative 0.6 divided by 2. All right, so let's calculate those here. So 8.2, that's going to be plus 0.6 because we're subtracting a negative, divided by 2, so that's 4.4. And then here, this is just going to be 8.2 minus 0.6 divided by 2, so 3.8. All right, so let's determine the period here. So remember what we said, that what we're given is from the max to the min, so that just represents half a period. So 3:38 to 10:08, so 3, 4, 5, 6, 7, 8, 9. So that's 6 hours plus another half an hour. So our period is 6.5 hours, but of course we want to multiply that by 2, since that 6.5 hours only represents the half of the period. So it looks like that's going to be 13. Okay, so that means that our K value is just going to be 2 pi over 13. All right, now let's figure out what our phase shift is going to need to be. So since I'm starting at 12 a.m. and it's my maximum that occurs at 3:38, that's a pretty, so I think what I'm going to do is I'm going to use the fact that the maximum is at 3:38 and work with a positive cosine function. So again, the trick I use is to work with an phase shifted function. So if I just start with my maximum at 0, okay, so I know my function looks something like this, but I don't want my maximum to be occurring at 12 a.m. on June 1st. I want it to occur at 3:38 on June 1st, which will be a little later on. So I want my maximum to occur somewhere here, okay, 3:38 to the right. Okay, so I'm going to be moving my function to the right, but it's given to me in terms of hours and minutes. I'm going to need to turn this into a decimal. Okay, so here, let's determine what that's going to be. So 38 minutes out of 60 in an hour is going to represent a decimal of 38 divided by 60 is 0.633. Okay, 0.633. All right, so that means that my phase shift, okay, is going to be 3.633 hours to the right. So 3.633 to the right. All right, and so now we can create our model. Okay, so we have y is equal to, so again, it's a positive cosine function, so our a value is 4.4. All right, cosine of our k value is 2 pi over 13. And then we said we were going to move it to the right by 3.633. So that's going to be x minus 3.633. All right, and plus our c value, which is 3.8. All right, so since they specifically asked us to determine a model, we need to specify what these variables mean. So here, where y, where y is height relative to sea level, okay, and x is time, and we'll do this in hours, okay, from 12 a.m. June 1st. All right, so I need to specify exactly when we're measuring from. So we're measuring from 12 a.m. June 1st. All right, so here's our model. So now what is it they want us to do with this model? They want to know when it's exactly at sea level. So in other words, they want to know the times when our y value is going to be equal to 0. So what we're solving is 0 equals 4.4 cosine of this whole big input. Okay, and what we have is a linear trigonometric equation. All right, so step number 1 is to isolate my trigonometric ratio. So cos of this whole big thing. Okay, when you're doing a problem like this, one thing you need to be careful of is not to miswrite anything. Okay, whoops. We're actually isolating, so we want that to be equal to, so we're going to bring our 3.8 to the side, so it'll be negative 3.8 over 4.4. Negative 3.8 over 4.4. So I'm not going to calculate this. I'll just put this in the calculator as is so that I can get a more accurate answer. All right, so now that we have step 1 of our algorithm completed, in other words, a single trigonometric expression equal to a number, I now find my 2 basic answers. One of those will come from inverse cosine, and the other one will come from my related angle identity. So we have that 2 pi over 13 times x minus 3.633, okay, is either equal to, well, inverse cosine of negative 3.8 over 4.4. And what's that equal to? That is, so inverse cosine of negative 3.8 divided by 4.4, and that looks to be 2.61. Okay, or it's going to be 2 pi minus 2.61. All right, and let's get that here. So 2 pi, 2 times pi, minus 2.61 is 3.67. All right, and so now that we have that, we can go to step 3, which is to isolate x. So x is going to be equal to, and let's work with the 2.61 first. So here I'm going to multiply by 13, divide by 2 pi, and then afterwards add 3.633. So let's do that here on the side. So 2.61 times 13 divided by 2 times pi. Make sure you put that one in brackets. And then we're adding 3.633. And that gives us 9.03. Okay, or it can be equal to that number with the same operation, so 3.67. So 3.67 times 13 divided by 2 times pi, and then adding 3.633. Okay, and that's 11.23. All right, so let's just check on Desmos that we have the correct answer, at least for these two. Okay, so I have this already set up here. So if I plot this function and I want to determine where it's equal to 0, well, I see 9.04. Okay, close enough to what I have. And here 11.23. So got that there. And then, of course, this is just going to repeat itself every period. Okay, so let's recall what the period is. So the period was 13 hours. So that means x is equal to 9.03 plus 13n, or 11.23 plus 13, and I'll use m here. Now you might be wondering why I'm not just listing the answers. Well, this is because I realize that this is at the 9th hour after 12 a.m. June 1st, but I'm going all the way to July 31st. So this is going to be a lot of answers. All right. So there's definitely would prefer not to list them. But of course, N and M just can't be any integers, I need to figure out which integers it can be. So I know I need n to start at 0 and m to start at 0 because I want to include 9.03 and 11.23. I'm not interested in anything less than 0. So these are going to be my first two answers, because if I subtract 13 from either of those, I'm going to get a negative answer. Okay, so I need to figure out what range of values n can have and m can have. I know it starts at 0. What's going to be the last one? And this is where we're going to use a trick that we saw in class, where I'm going to figure out how many hours in total there are in this interval of time, and then I'm going to use that to help me determine my n. Okay, so let's figure out how many hours there are in 61 days. So 61 days times 24 hours in each day. So we have 1,464 days. So we have 1,464 days in total. Okay, so what I'm going to do is I'm going to solve for each of these things equal to 1464, and that's going to help me determine what my maximum value for n and m is going to be. So let's do 9.03 plus 13n equals 14.1464, and let's solve that. So it's going to be 1464 minus 9.03, and then divided by 13. And we have 111.92. But this 0.92, remember, n can just be an integer. Okay, so I'm not interested in this. If I went to n equals 112, I'd be going too far. Okay, so here I have that n can be equal to 0, 1, all the way up to 111. Okay, and we shouldn't assume that it's going to be the same for m, so we should definitely calculate it. All right, so 11.23 plus 13m equals 1464, and so m is going to be equal to, and let's calculate that one. So 1464 minus 11.23, and then divided by 13, and that's again 111.75. So again, not interested in that component. So here m can also be equal from 0, 1, and so on, all the way to 111. All right. Now, since they didn't specify that I had to give dates, okay, if it's not specified, I get to choose how I give my answer. So my answer is given as hours from 12 a.m. on June 1st. All right. So quick recap here. First of all, find your model using all the basic information that's given. Determine your parent function and any phase shift that's needed. Okay, once you have that, determine what they're looking for. Here they were looking for a height of 0. Solve it using your algorithm. First, isolate the trig ratio, then use inverse cosine and the appropriate related angle identity to find your first two answers, solve for x, and then use the periodicity to determine the answers. And here we use the formula to describe all these answers because, well, there's a heck of a lot of them. All right, that's it for this one.